Okay, so here we have our displacement time graph as we've seen. In blue, in the table we have Alex the Awesome, which is represented by red, and we have Finbar the Fantastic in the blue. We've just calculated the velocity for Finbar the Fantastic, okay, and now what we're trying to do is find the velocity of Alex the Awesome at his two sections D and E. The important part to realise with this expression is we're just using information from the graph to solve for velocity. If I told you that Finbar had travelled 300 metres in 60 seconds, which he has, would you be able to calculate the velocity? Yes, you would. What makes it a little bit more tricky is that we're dealing with graphs and the G word, which confuses us. So can someone please help me write my first line of work for Alex the Awesome's velocity D? Phil. So I would write VD equals DF. What's DF stand for? Minus DI divided by minus, which is the same as saying change in displacement divided by change in time, which we know is the equation for velocity, correct? Change, yeah. Yep. So, underneath there I would write what, Phil? So 600 is your final velocity up here. So you pick that point there and that point there. Could we pick any other point on that straight line? Yeah. Does the gradient of a line change if it's straight? Okay, so we can see here along that entire section there, we could have picked any of those 2 points. Which means if we're looking at our graph, we could have used this, or this, or this, or this. Phil's decided to use 600 over 120. There's nothing wrong with that. So he has said 600 minus what? 0 divided by?
120.
Good. The initial point of 0, 0 is always a nice one to use. Makes our maths a little bit kinder. That's the same as saying 60 divided by 12, which is?
5 meters.
Now, if we look at this graph, that makes sense, doesn't it? Because we can see that for the first 60 seconds, Finbar the Fantastic and Alex the Awesome are running next to each other. So that makes perfect sense, doesn't it? The gradient would be the same. The difference is how long Alex does that for. So who would have travelled further in that direction? Alex the Awesome. But at 60 seconds, they are both travelling the same distance, correct? We then come back for our VE. How do we go about VE? Thank you, Corey.
So 500.
Yep.
Subtract 600.
Yep.
Over 120.
Oh, is it 120?
Divided by.
Yep. Sorry. Is it 120?
Yeah. Wait. Oh yeah. Sorry. 180. Subtract 120.
Okay. Good. So we get what? Negative.
100.
Divided by?
60.
Which would give us what? Alex the Awesome, you can finish us off. Negative 1.67 metres per second. Okay, and does a negative velocity make sense? Why does it make sense? Michaela? He's coming back towards his origin.